This is the seventh video of the series Business Forecasting. We were discussing time series analysis and today's video is about forecasting accuracy. So although we were discussing accuracy, there are two different terms, accuracy and precision, that need to be discussed. Accuracy is more related to central tendency of a data and precision is related to the spread of the data. In order to illustrate, I have given you two diagrams. The diagrams towards the left, you can see the stumps. I have shown a cricket pitch here where the stumps are the target and the delivery lines have been shown also. This particular bowler towards the left is bowling 6 deliveries, you can see here, but the deliveries are too much different from the target, that is they are deviated from the target. But if you take the average line of these deliveries, since they are equally spread towards both the direction of the target, then the average might come towards the target. That means although they are much distant or much different from the target, average of all of them will come in the target. So this is an example of accuracy because it is directed toward the target, but the result is highly imprecise because the spread is too much. On the contrary, if you check the right hand side diagram, the accuracy is too poor. That means if you take the average, it will come somewhere around here and it is much different from the actual target. But the spread is very low. That means the average distance of the deliveries or the lines from this center is quite low and they are clustered towards a particular point. So the precision is quite high, but they are actually too much inaccurate. So for example, in case of cricket, you can see here if this is the delivery, then all of these deliveries will be wide balls. But the precision is very good, accuracy is too poor. But why are we discussing all these points here? Because after a few slides we will see that the various measures of forecasting accuracy, when we will discuss, some measures are applicable in order to estimate the forecasting accuracy, while some other are for the precision. Okay, so in this slide we have defined residual. Residual is nothing different from what is called is error. So error and residual are both synonymous and exactly the same thing. But the only thing that you need to remember here is residual or error is defined as actual minus forecast. That is, you take the difference of forecast from the actual. This is the correct definition, and forecast minus actual is the wrong definition. So never do that. Always subtract forecast from the actual and not the other way around. That is actual from the forecast. So this definition is wrong. This one is correct. This is the only thing that we need to remember. So these are the various forecast estimates that we are going to use here. So basically 6 estimates are there. You can read from here. MFE stands for mean forecast error. MAD is for mean absolute deviation. MAC is for mean squared error. MAP is the mean absolute percentage error. MP is the mean percentage error. And finally TS is for tracking signal. Now looking at this formula, you can figure out how these will be calculated. So for example, MFE is the average of simply the residuals, that is the AT minus FT terms. MAD is absolute value of the residuals and average of that. MAC is calculated by taking the average of the squared residuals, that means the square of the AT minus FT terms. Now the MAPE and MPE terms are relative measures of accuracy. That means you are measuring your MAD values. The MAD will give you an absolute measure of error. But if you calculate the MAP values, MAP, so that is the relative measure compared to the MAD. Similarly, if you are computing MPE, that is a relative measure of MFE. So why should we use relative measures? In some cases we have to use relative measures. For example, if the bases are different, for example, you are comparing same units like same items or same attributes, but for two different companies or for two different economies or two different systems, then the base changes. So if comparisons are made using absolute measures of accuracy, then those comparisons are not good. So in those cases you have to use the relative measures. So In case of MAD, the relative measure is MAP. In case of MFE, the relative measure is MPE. And finally, the tracking signal. Tracking signal is the ratio of these two. So in the numerator, you have the AT minus FT terms, that is the error terms, and in the denominator, you have MAD. So unlike the other measures of accuracy, that is this 5, the TS value will be calculated in each period, not only in the final period. For others, we will calculate the MAP, MP or MFE or MAD or MSE in the last period. That means the average of all the periods in the last period. But for TS measure, we will calculate the TS value in each period. So let us come to the spreadsheet in order to illustrate this formula and apply these formulas so that you can understand it very well. So this is the spreadsheet. This is the same spreadsheet that we used in Winter's method in video number 6. So that is why I am not again deriving the FT terms here. That means the forecast terms are already calculated in video 6. If you are wondering how these are calculated, then go to video 6 and watch them. So I am only doing the error analysis or residual analysis here in this video. So this is an image copied from the slide in order to just match the slide and the calculation here and show you. So first of all, calculate this is the residual CET is equal to AT minus FT. I told you already that the error or residual is the difference between actual and forecast. So do that here, actual minus forecast. So this is the actual and this is the forecast. As simple as that. This is the residual. And the absolute of that residual can be calculated by ABS function. ABS of this is the absolute value, and then the square of this is the squared value, obvious. And if you do the AT divided by AT, that means this ET value divided by this AT value, this gives you the relative measure, and then absolute ET divided by AT, this is another relative measure. Then I am leaving this blank right now, later on I will fill this up. Now if you drag this down, copy this to the end, see I have made this few rows hidden here. So from row number 23 to 45 is hidden here in order to show you the full calculation. And then this is once this is copied here, you will do the averaging. So the averages will be calculated here. Average of this see clearly, this is the average of this ET terms. That means this average is calculating this one, MFE. So this is your MFE. If you take the average of this column, this absolute ET, this will give you the MAD. So this is your MAD. Then if you take the average of this is the squared error, and you know that the average of squared error is your MSE. So this is your MSE. Then finally ET by ATC, in this expression the numerator is ET, that is AT minus FT, and the denominator is AT. So if you do this and then take the average, this gives you MPE. So this one. Finally, if you do the average of this, then it gives you MAPE, this one. So these 5 are covered now. Only thing is left here is the TS value. So how will you calculate the TS value? In order to calculate the TS values, we need to calculate the RSFE value. What is RSFE? RSFE stands for running sum of forecast error. So this is running sum of forecast errors. RSFE is nothing but a fancy term for the cumulative errors, cumulative ET value. That is the RSFE. How to calculate? Simply, the first ET will be the first RSFE, and for the second ET plus the first ET. For the third this one plus this one. In this way, the ET will accumulate, and this is called the RSFE. And what is MAD? We already know what is MAD. This is the MAD. But now, instead of doing the MAD finally in the last period, we are calculating the MAD value in every period. So that means in the first period, we will take the average of absolute value and the absolute value. So that means from J17 to J17, that means only one value, J17. But I am writing this in this way because you can copy this now. So if you can copy this now here, it becomes J17 to J18. So average of these two. Then if you copy this here, it becomes J17 to J19. So these three values. See, I have made this J17 to $J 17. That means fixed it, so that when I copy this down, the J17 value, the first value, does not change. Only the second value is changing. So which is ensuring that the average is getting computed for this ET term for that period. So now if you complete this, in the last period, this will be the average of all these, and eventually this will be the same as this. So you can check here, these two entries are equal, has to be equal, because this is also average, this is also average for the entire column. Only difference is that this average is taken for each period, like the running average. And now what is TS? TS is your RSFE divided by MAD. So therefore this is updated in each period, and this is your TS values. There is no need to take any average here. So as you can see, by definition, your TS was this. The numerator is called the RSFE and the denominator is MAD. So this is your TS calculation. So now I will delete this, and so this is your entire calculation. Now I will make three plots here. The first plot is, I am zooming this out so that you can see the plots well. So first of all, I will plot the actual versus receipt forecast. So first you select the period and AT values together. Then you press the control key in your keyboard and select this FT values also. Once this is done, you go to insert charts and here line chart, this one, this option. So this will give you the forecast versus actual. You can delete this one. So first you select the AT column entirely, then you press the control key in your keyboard, then select the FT column completely. Once this selection is done, you go to insert, then line chart, and this option, 2D line and line with markers. Once you do this, you'll get this figure, and this is your AT versus FT graph. Now you can modify this graph, you beautify this graph in many possible ways. I am just not doing that here because that is a wastage of time for me. You can change these names also, and maybe you can select some other format of graph, change these colors also, change this axis also. I'm not doing all those things here. You can do that yourself in Excel. So this is the first type of graph you can build. Another graph you should develop here is your TS values should be in the control limits of -2 to +2. So you write two control limits here, -2 and +2, and select these three columns together in this way, and again go to insert chart and this particular option. Once you do this, you will develop this control chart. This control chart is for TS values. See the upper limit, this gray line is for +2, and this orange line is for -2, and this blue line is the actual TS values, that is this one. You can again change these legends here and style of the graph or whatever you think is appropriate. I'm not doing that. So this is another plot. The third plot that can be generated here is that your residual values, that means your ET values, this should be in the control limits of -2 into square root of MSE and then +2 of square root of MSE. So now let us implement that control limit also, that is -2 into square root of what is MSE. MSE you have calculated here, K50. So you have to fix it anyway because you are going to copy it down. So this is the lower control limit, this is the upper control limit, just change this to +2. So these are the two control limits, you copy them down, and then now during selection you select the ET values from here, then press Ctrl in your keyboard and select these two columns together. Once this is done, again you go to insert chart and this one, then you will see the control chart for the residuals. So these are the three plots that can be generated from your data, your residual analysis. Now what should be the interpretation? That is more important than building beautiful graphs. So interpretation from the actual versus forecast data is the forecast should follow the actual. That means there should not be too much differences between forecast and actual in the plot. Here in this case you can see there is considerable differences also. So that means the forecasting system chosen by you in this particular case, you see that you have chosen which system. You have chosen Winters method with 0.1, 0.2 and 0.3 smoothing coefficients. So that system, that particular model is not a very accurate model for this problem. Now in the second graph, that is the TS graph, you can see that the TS values are significantly lying outside the ±2 control limits. So that is also an indication of poor bias. Poor bias. And residual plot also, you see there are points outside the control limits, and moreover you can see that more number of points are above the zero line. So you note the zero line here, this is the zero line. You can see that more number of points are there above the zero line compared to the points below the zero line. So that means what is happening is your residual ET was your AT minus FT. This is mostly greater than 0, which means your FT values are mostly less than AT values, which also means your forecasting system is underestimating underestimating the actual, not very accurate. So for an accurate forecasting system, three things should happen. First of all, the forecast line and the actual line should match with each other to the maximum extent possible. Secondly, your TS value should come mostly between plus minus 0, plus minus 2 control limits. And thirdly, your residual value should come within the plus minus 2 square root of MAC control limits, and equal number of points should lie above and below the zero line. Equal means almost equal. So if these three conditions are there, then you will say that my forecasting system is good or accurate. So this is all about calculation in spreadsheet for any forecasting accuracy analysis. So let us come to the slide once again. Return to our original accuracy versus precision slide, and now let us classify our error estimates according to accuracy and precision. We can say that our MFE and MPE measures are related to accuracy. Why so? Because you see, these are the deviations from the target. Now these deviations can be as large as possible. For example, the forecast error can be minus 10,000 error, suppose. All you need is a plus 10,000 in order to see your MFE value equal to 0. So that means even if the spread is too large, your MFE value does not take care of it, provided that the spread is equal towards the equal in both the sides of the target, and this is the target. So that means MFE is primarily focused on the target or the accuracy, not the spread. And since MP is the relative measure of MFE, that is also a measure of accuracy and not precision. But unlike this, your MAD and MAP is the relative measure of MAD, as you can see, and MSE also. These are primarily focused on your precision. Why? Because if this minus 10,000 and plus 10,000 thing happens here, then MAD and MSE both will consider it, because MAD will take 10k from here and 10k from here, because it is taking the absolute value, and MAC is taking 100 and 100k here, because it will square it. So even if the inaccuracy is high and not equal, and equal in both the sides, MAD and MSE will not cancel out that thing and consider that as a part of inaccuracy, and hence represent it as a large spread of the forecasting system. So therefore we are saying that MAD and MSE and also MAP are the measures of precision. Now finally we have a measure TS, and if you have noted already that TS is your RSFE divided by MAD. You know that RSFE is computed directly from MFE. So therefore RSFE must be a measure of accuracy, and then MAD is a measure of precision. So the numerator is a measure of RSFE and the denominator is a measure of precision. So therefore TS is perhaps trying to keep a balance between measuring accuracy and precision. So in this way you can classify the various measures of forecasting accuracy. Now let us see which measure to use when. So first of all, MFE, the time series contains less spread. So when the time series has less spread, you will use MFE. So for example, this is your time series, the spread is less. If this is the situation, or say some trend is there also, but the spread, overall spread is less, in such a case you will use MFE. And when to use MP, suppose some kind of comparison has to be made. Which kind of comparison? For example, you are trying to compare the demand of two different departments or two different companies. The underlying variable to be forecast is demand, but since the companies are different, the bases are different. So absolute measure MFE will not work. You have to take relative measure, which is MPE. Similarly, suppose you are trying to measure the accuracy in two different points of time, like the demand in 2000 versus the demand in 2022. So many factors have been changed. So the absolute demand also have been changed. So it is not possible to determine the forecasting accuracy using MFE in such a case. You have to go for a relative measure, which is MPE in this case. Then if the time series contains considerable spread, like instead of this, your time series looks like this. So as you can see here, the spread here is quite large. In all those situations, you are supposed to use MAD or MAD. And similarly, MAD is a absolute measure. The corresponding relative measure is MAP or MAP. So as in case of MPE also, in case of MAPE, if comparison has to be made or the bases are different, then you cannot use MAD. In that case, you have to use MAPE. The number 3 is MSE. In this case also spread will be there, but unlike MAD, one value or more than one value will be there, where there will be an upper spike or lower spike. That means it will be an outlier compared to the rest of the data. If such a data is given to you, then instead of using MAD, you should go for MSE. Because since in MSE we are squaring the errors, and therefore any such situations like outliers will be penalized more compared to the MAD. So in those cases, MSE will be a better measurement. And finally, TS. If you want to measure the bias on a dynamic basis, that is persistent bias, in that case you will use the TS. In case of TS, we are updating the TS in every period separately, as we have seen in the spreadsheet also. Every period a different value of TS is being calculated, and then we also plotted that against -2 and +2 in the control chart. So therefore you are persistently checking the bias, not just relying on only one value of the bias that is given by your MFE. So in those cases you can use TS. So that's all about forecasting accuracy. In the next video we will see how to optimize the parameter of any forecasting system, and by optimizing we will minimize the errors. Until then, thank you for watching this video and being with me.